Hello all, this is Vignesh here welcoming you all to my channel Educators Inc. The topic for today's discussion is discovery of protons.
The topic of today's discussion is discovery of protons. In the last videos, we had studied about the structure of atom, the subatomic particles, electrons, neutrons, protons, Dalton's atomic theory, as well as about the discovery of electrons and the cathode ray experiment. In this video, we shall study about the discovery of protons. Before going to the discovery of protons, we shall have a look at the structure of atom. The figure shown here is the basic structure of atoms. The structure of atom here contains three subatomic particles: electrons, protons and neutrons. The protons are shown in green color, the neutrons are shown in blue color, and the electrons are shown in red color. The protons and neutrons together constitute the nucleus of the atom, whereas the electrons revolve around the nucleus in a circular orbit as shown. Now, after having a look on the structure of atom, we shall move to the main topic, that is of discovery of protons. In 1886, German physicist Eugene Goldstein carried out a modified cathode ray tube experiment in which he used electric discharge in a modified discharge tube with a perforated cathode. In this experiment, he discovered positively charged rays which he named the canal rays. Canal rays are also known as anode rays. Now we shall study about the experiment which Eugene Goldstein carried out. It contains the same apparatus that was used for the cathode ray experiment. Now you can observe here, this is the same apparatus that was used for the cathode ray experiment. It contains a glass tube with two electrodes, anode and cathode, but the only difference in this experiment is the cathode is perforated one, that is, it has holes in it, as you can see here. Then these two electrodes are connected to a high voltage source. Gas at low pressure means the gas inside the tube is maintained at low pressure by connecting the tube to a vacuum pump. Then the red glow is achieved because here the glass tube is coated with a fluorescent material. So whenever an electric current is applied to anode and cathode through the high voltage source, an electric field is created between them, and this electric field makes the gaseous atom to ionize. At this point, the anode releases positive ions as shown in the figure, which move through the cathode and hit at the fluorescent material which glows red as shown in the figure. Now, since these positive ions or this stream of positive ions travel in the opposite direction to that of the cathode rays, these rays or this stream is known as anode rays. Now we shall see certain properties related to protons. Unlike cathode rays, mass of positively charged particles depend on the nature of gas present in the cathode ray tube. These are simply the positively charged gaseous ion. Since I already told you that whenever an electric current is applied to anode and cathode, electric field is generated, and this electric field makes the gaseous atom to ionize, that is to form the cations. The atomic masses of gases are different. Therefore, the mass of positively charged particles also will be different according to the gases, and therefore the charge to mass ratio of the particle depends on the gas from which this originates. Some of the positively charged particles carry a multiple of fundamental unit of electric charge. This means that consider a positively charged body. This does not mean that it is made up of only a one single unit of positive charge. It may contain many positive charges and negative charges, but the overall charge depends on the number of which charge is maximum, that is positive or negative. The behavior of this particle in the magnetic or electric field is opposite to that of the electrons or cathode ray tube. Hence we conclude this video.
Hence, we conclude this video. In the next video, we shall continue with the discovery of neutrons. Please like, share and subscribe to my channel by clicking on bell icon. Thank you.